Hello everyone, section 4.1 translations. Example 1, we're going to use some vector component notation to name this vector. This is vector starts here at P at our initial point, goes here to Q at our terminal point. It looks like a ray because it's got the arrow, but that just indicates the direction. It's actually more like a segment. It's more like a segment with direction. So it has a starting point and an end point. It doesn't continue past Q, but it does have a specific direction starting at P going to Q, unlike a segment. So the notation is P, Q. And again, the notation even looks like ray notation, but it's half of a ray, just the top part. So that is vector PQ. This vector starts here. It goes to the left 1, 2, 3, 4 spaces. So left 4 spaces is a -4 direction, and then it goes up 1, 2, 3, 4, 5. Up is a positive direction. 5 spaces. We use these angle brackets to indicate that this is a vector, not a point. So this is our component form. That's example 1. Example 2, translations using vectors. We're going to answer all of these questions using this diagram. Find the image of T under the translation described by the vector 2, 3. So again, we know it's a vector because it says vector, but also because of the angle brackets. This indicates that we're going from T, we're going 2 spaces to the right and 3 spaces down. So here we are at T. We go 2 spaces to the right and 1, 2, 3 spaces down, and we end up 3 spaces down, 3 spaces up, positive. 1, 2, 1, 2, 3. We end up at point R. All right, when we go from S to U, U is over here, we're going to go left 1, 2, 3, 4 spaces, and then we're going to go down 1, 2, 3, 4, 5 spaces. Left 4, down 5. Find the vector that describes the translation from U to S. So now we're going right 1, 2, 3, 4 spaces, and up 1, 2, 3, 4, 5. 4, 5. Right 4, up 5. Okay. Find the image of A under the translation -4, 4. So here we are at A. -4 is 4 spaces to the left. 1, 2, 3, 4. And a +4 up. 1, 2, 3, 4. And we are back at point R again. Part E. Describe the image of A under the translation -1, +4. So we'll go to the left 1, up 4, 1, 2, 3, 4. We end at point D. Going from T to S. From T to S we go right 1, 2, 3, 4, 5, 6, and up 1, 2, 3. Right 6, up 3, gives us the vector 6, 3. Part G, we're going from B to E, down 1. I'm sorry, let's go right 1, 2, 3, down 1. Right 3, down 1. And that is example 2. Example 3. Translation maps point A to point A prime. This means it's the image. That's a notation. Prime notation means the image. So we're going from A to A prime. Write the rule for the translation. So the rule for the translation, do that. I got space here. We take the initial point x, y, and it gets mapped to what? What do we do to the 2 to make it a 5? Well, we add 3. So what do we do to the x? We add 3. What do we do to the negative 3 to make it a 1? Go from negative 3 to positive 1, we add 4. So what do we do to the y? We add 4. So instead of vector component notation, this is a different notation for a translation. It's what we call the rule for the translation. What are we doing to the x? We're adding 3. What are we doing to the y? We're adding 4. Okay. Give the coordinates of b prime and c prime for b and c. Okay, so here we're going to apply this rule to these points. So when we're adding 3 to negative 4, we get negative 1, so b prime will be negative 1, and negative 3 plus 4, positive 1. C prime, 2 plus 3, 5. 7 plus 4, 11. So B prime and C prime. All right. From D to D prime, what was the preimage? What was D if D prime, if the result is negative 1, 11? So now we're going backwards. What did we add 3 to get negative 1? Well, we must have added it to negative 4. So D, because negative 4 plus 3 is negative 1. What did we add 4 to get 11? 7. 7 plus 4 is 11. So the original point D must have been at negative 4, 7. How far does each point move under this translation? So if we go to the right 4, or to the right 3 and up 4 from any point. 2, 3, 2, 3, 4. If we went from here to here, how far have we traveled? 3, 4. And we can do distance formula or Pythagorean theorem. We do distance formula. D equals square root. And again, I'm using 0, 0 and 3, 4. You can use any 2 points following this translation. So we're going to have 0 minus 3 squared plus 0 minus 4 squared gives me square root of 9 plus square root of 16, square root of 25, or 5. So how far does each point move under the translation? 5 spaces. Find the length of segment BC and the length of segment B prime, C prime. So again, we're going to use distance formula. So BC, we use these coordinates. B prime, C prime, we're going to use these coordinates. And I've got some blank paper here. So BC, again, distance formula equals square root negative 4 minus 2 squared plus negative 3 minus 7 squared. Negative 6 squared, 36, plus negative 10 squared, 100, equals square root of 136, which, can we get that into a simplest radical form? You know what? We probably can, but I'm going to leave that, and you're going to see why in a second, because I'm comparing the length of BC to the length of B prime, C prime. So I'm going to leave that as square root of 136. Now, let's do B prime, C prime. D equals. So I'm going to change this. Change my notation. Length of BC, segment BC. Length of segment B prime, C prime. Okay. Square root -1 minus 5 squared plus 1 minus 11 squared. -6 squared is 36. -10 squared, 100. And we're back to square root of 136. And this is because translations maintain length. It's an isometric transformation, or a rigid motion in our book. Okay, so this square root 136, square root of 136. All right, find the midpoint of segment AD and T. All right, so M to M prime, give the coordinates of M to M. All right, so M is the midpoint of segment AD. So here's A, here's D. So midpoint formula is find the average of the x's. So average 2 plus -4 divided by 2, and -3 plus 7 divided by 2. You get -2/2, that's -1. 4/2, that's 2. So this is point M is 1 comma -1, 2. I have a typo there. Let's see if we can figure that out. Typo on the answer key, it says 2, 6, and it really should say -1, 2. Now, we're going to take translation T, which maps M to M prime. So we're going to take and apply this rule to this point to find coordinates of M prime. So -1 plus 3 is 2, and 2 plus 4 is 6. So M prime's coordinates are 2, 6. Now, give the coordinates of the midpoint of A prime, D prime. So now we have A prime is here, and D prime is here. So we're going to find the coordinates of the midpoint A prime, D prime. So we go 5 plus a -1 over 2, 1 plus 11 over 2. This is going to be M prime. And we get 5 minus 1 is 4 divided by 2 is 2. And 12 divided by 2 is 6. And what do we notice? Is the same point found in part F? Yes. They are the same coordinates. Okay? Example 4. The vertices of triangle ABC are given. Translate triangle ABC using the vector -1, -2. Now, I could plot these, and then I can move each point left 1, down 2, or we can apply a rule like we did up here in example 3. Now, this particular rule would be subtract 1 from the x, subtract 2 from the y. So when we do that, we get A prime, subtract 1 from the x, -1, subtract 2 from the y, 1. B prime, subtract 1 from the x, 1, subtract 2 from the y, 2. C prime, subtract 1 from the x, 0, subtract 2 from the y, -2. And there's the answer to example 4. Example 5. Write the rule for the translation. We go from triangle ABC to triangle A prime, B prime, C prime. So A, B, C to A prime, B prime, C prime. A to A prime, we go down to the right, 1, 2, down 1. So X to Y, it's mapped to. What are we doing to the X? We're moving it to the right 2. So X plus 2. What are we doing to the Y? We're moving it down 1. Y minus 1. And there's our rule for the translation. Now this is going to work. I didn't have to do A to A prime. I could have done C to C prime. Right 2, down 1. B to B prime. Right 2, down 1. The rule applies to all of the points. That's example 5. Example 6. Graph quadrilateral ABCD with the given coordinates and its image under this rule. So A, 1, negative 2, 1, negative 2. So there's A. B is at 2, 1. There's B. C is at 4, 1. And D is at 4, negative 2. So there's C, there's D, and there's our quadrilateral ABCD. Now we want to plot A prime, B prime, C prime, D prime, going left 1, up 4. Left 1, 1, 2, 3, 4. Here's A prime. Left 1, up 4, 1, 2, 3, 4. B prime. Left 1, 1, 2, 3, 4. C prime, and left 1, 2, 3, 4. There's D prime. And there's the image of ABCD, A prime, B prime, C prime, D prime. Example 7. We're going to graph segment RS with these coordinates. Then we're going to graph its composition of translation. So we're going to do this translation, and then we're going to do this translation. We're going to end up with R double prime, S double prime. Okay, so R is at negative 8, 5. So here's R. S is at negative 6, 8. There's S. And this is our initial segment. We're going to go left 1, up 4. Left 1, up 4. 1, 2, 3, 4. This is R prime. Left 1. 1, 2, 3. I'm off the paper here. 4 for S prime. That's R prime, S prime. And now we're going to go to apply to this segment. We're going to go to the right 4, down 6. To the right 4. 1, 2, 3, 4. Down 6. 1, 2, 3, 4, 5, 6. And this is now R double prime. S double prime, we're going to come down to the right 4. 1, 2, 3, 4. And we're down 6 again. 1, 2, 3, 4, 5, 6. This is S double prime. And there's the answer to example 7. Example 8. Now, there's a shortcut to doing this. What if I had gone directly from R to R double prime? 1, 2, 3 to the right, 1, 2 down. Negative 1 plus 4 is X plus 3. And 4 minus 6 is y minus 2. Right 3, down 2 is the rule. So a quick way of coming up with this, negative 5 plus 4 is x minus 1. And negative 3 minus 6 is y minus 9. This is the rule for translation T. Thank you very much.